Hello students, welcome to my channel Positron. Dear students, today's topic is a relative velocity in two dimension. Already in my video, I have made the video that was the relative velocity in one dimension. Again, I like to, before beginning this journey with you all, let's talk the basics of relative velocity. Why do we use relative velocity? Actually, dear students, when we apply a concept, we apply the concept to make the problems easy, not to make them tough. People generally complain to me that relative velocity is a bit confusing. It is not so, really. Dear student, I have made the video for relative velocity in one dimension. You can go through my videos. How relative velocity is fruitful are beneficial to us in solving the problem. Dear students, look here. Let the two vehicles are A and B, okay, and they are 100 kilometer apart. Let the two vehicles A and B are 100 kilometer apart, and their velocities are 60 km per hour and 40 km per hour. They are approaching towards each other. Let me watch whether, yes, I'm watching whether proper board is in the camera or not. Now, dear student, the problem is that I'm going to discuss with you all that why do we use relative velocity, how it is beneficial to us, how it can make the problems easy. Dear student, let the two vehicles are A and B, they are 100 km apart and they are approaching towards each other with the velocity 60 km per hour and 40 km per hour. Question is that when and where they will cross to each other. If you do not apply the concept of relative velocity, then hardly apply. Let t time after two vehicles overtake crosses to each other. In that t time, the distance traveled by this one, this is equal to, distance is equal to, that is velocity equal distance upon distance equal to velocity into time. This is velocity 60 and time is a they crosses to each other t time after. So the distance traveled in t time by this one is 60 t and by this vehicle d2 is equal to 40 t. Now let they meet here, right? So this distance in t time it will travel 60 t distance, this is, and it will travel 40 t distance, and then when you will add these two it will equal to 100 kilometers. So 60 t plus 40 t, that is equal to 100, or 100 t is equal to 100, or you can say t equals to 1 hour. It means 1 hour after they will cross to each other. Dear student, in 1 hour it will travel 60 kilometer distance and this one travel 40 kilometer distance, and 60 plus 40 equals to 100. So if you do not apply the concept of relative velocity, the same thing you have to follow. There is no any other option. But if you apply relative velocity, what happens? Dear student, now I am going to apply the concept of relative velocity while solving this problem. You say velocity of A, dear student, you say velocity of A with respect to B, that is VAB is equal to VA minus VB, right? What does mean by this concept? Relative velocity of A with respect to B, that is equal to VA minus VB. What does mean to is, that is VAB, velocity of A with respect to B, or velocity of A observed by B. Or in general you can say velocity of A with respect to B means velocity of A when B is at rest. What is the velocity of A observed by B when B is at rest, right? So VA minus VB, velocity of A with respect to B means velocity of A when B is at rest, and that is VA minus VB. Dear students, the same concept, this concept is a very useful if you just know the meaning of this language. That in oftenly if you solve the riverboat problem, there is a question in the question paper. It is given that the velocity of boat in still water. In still water means when water is not flowing, means when water is at rest. At that moment, velocity of boat with respect to river it is given. Yet it is not written directly that velocity of boat with respect to river, but dear student, when it is given that velocity of swimmer in a still water, it means it is giving you the velocity of swimmer with respect to river. Now dear student, the same concept I am applying, I am going to apply. We have to find out that what time they will meet and how much distance they will travel. Now dear student, let t time after they will meet. That's right, I am going to apply the concept of relative velocity. I am considering here VAB, velocity of A with respect to B, and that works out to be VA minus VB. Now dear student, VA, this velocity, it is moving positive x direction, that's why I am considering it positive, minus VB. Now it is approaching to us in negative x direction, that's why I am writing so minus 40, and so it turns out to be 60 plus 40 is equal to 100 kilometers per hour. Now dear students, you have got VAB, velocity of A with respect to B, that works out to be 100 kilometers per hour. Actually VAB, velocity of A with respect to B, means velocity of A observed by B when B is at rest. In this expression, actually B is virtually you can say that B is at rest. When you consider VAB means initially the two vehicles A and B are approaching towards each other with velocity 100 km per hour, with velocity 60 km per hour and 40 km per hour. But when you apply the concept of relative velocity, VAB means velocity of A with respect to B, means what would be the velocity of A when B is at rest. So VAB works out to be 100 km per hour. Now dear student, again we have to find out that what time A and B will cross to each other. Now you have applied the concept of relative velocity, means you have find out VAB means velocity of A when B is at rest. Now dear student, just suppose that when B is at rest, A has to travel this complete 100 km in order to cross the B. Question is that when B is at rest, A has to travel this 100 km entire distance to meet with the B. So what time they will meet? Now time is equal to distance. The time when A meets to B, when A crosses to B, time is equal to distance, that is 100 km, divided by velocity. Velocity of approach or relative velocity, that's why that is 100, and so it is a 1 hour, right? Now time is a 1 hour. Now dear student, in 1 hour, A will cross to B. In the meantime, in 1 hour, this will travel 60 km distance and this will travel 40 km distance. So you have got it very easily. Dear student, this is why we apply the concept of relative velocity. Now, very important thing. In the relative velocity, the questions that are asked in JEE Mains, NEET, they are based on three kind of problem. The first one is a riverboat problem. Second one is first is a riverboat problem, airplane wind problem. And third one is a Rain Man problem. Dear student, these two problems are similar. Either you say river boat problem, here river is replaced by wind and boat is replaced by airplane. So these two problems resemble to each other. So either you know river boat problem or you know airplane wind problem you can solve. And third one is a rain man problem, right? So these two problems we will discuss, and if you know river boat problem, easily you can say you can solve airplane wind problem. Now dear student, so we are going to solve the river boat problem. Dear student, very important concept that when we apply river boat problem or airplane wind problem or rain man problem, always we talk about frame of reference. First we talk about frame of reference. What the frame of reference is? Why do we talk about? Dear student, very important that in physics there are many quantities which are not actually absolute quantity. Absolute quantity, the quantity which can be defined independently. Motion is not absolute quantity. It cannot be defined independently. The motion should be defined with respect to plane, person or the object, and that plane, person or the object with respect to which all the motion in the world is calculated, called frame of reference. Frame of reference is what? Any place, person or the object with respect to which motion of this world is calculated, called frame of reference. In general, for the convenience, traditionally our coordinate system is our conventional frame of reference. Dear student, just I have said that motion is not absolute quantity. How do you prove? I cannot say that whether you are static or dynamic, whether you are at rest or moving, it is not only you decide, but it is the person, the observer also decide. Observer also has role to play. Let you are the two friends sitting to each other and talking to each other. Then both of you are at rest with each other. But what happens when a car is just moving side to you and a person sitting in the car? If you see that car is moving with the velocity speeding ahead, and you will see that the person sitting in the car also moving away from you with the velocity, and same happens. The person sitting in the car, when he watches you, you all are moving back with the velocity. Now, with respect to each other, both of you are at rest, but with respect to the person sitting in the car, you are not at rest. So, your position, your status is not defined by you, not only by you, but it also depends on the position of the observer, whether the observer is at rest or is in motion. So, frame of reference is what? Frame of reference is a place, person or the object with respect to which motion of the universe is calculated. Dear students, there is two type of frame of reference. First one is this is called inertial frame of reference, and second one is a non-inertial frame of reference. In general, actually we talk about inertial frames. At your level, we talk about inertial frame. Inertial frame is what? A frame which is either at rest or moving with the constant velocity is called inertial frame. Or all those frames in which Newton's law of inertia is followed is called inertial frame. Right? And second one is a non-inertial frame. All those frames which are having the accelerated motion. Inertial frame is what? A frame which is either at rest or moving with constant velocity. Moving with constant velocity. And non-inertial frame having acceleration. All those frames having accelerator are all those accelerated frames are said to be the non-inertial frame. Dear student, our earth is not only revolving but is spinning about its own axis also. It's revolving around the sun, right? And is spinning about its own axis. It has the acceleration. So Earth and every object lying on the Earth is the example of non-inertial frame because it has the acceleration. And now inertial frame, a frame which is either at rest or moving with the constant velocity, or a frame in which Newton's law of inertia is followed, called inertial frame. All those frames having the acceleration is called to be the non-inertial frame, or all those frames in which Newton's law of inertia does not hold is said to be the non-inertial frame. Dear student, let you are the two persons just enjoying a ride in car. You have bought a new car, your dad bought a new car for you, and you along with your friends are enjoying the ride of new car. Now, yet car is speeding, but all of your friends sitting in the car are at rest with each other. If you begin your journey, actual relative velocity or relative motion is what? Relative motion means relative displacement. If you are the two friends in this car and it is moving with the velocity from A, after time t, it reaches to B, right? Now, dear student, all it reaches to B, but there is no relative displacement between your friends. When the vehicle was at point A, you and your friend were at point A. When vehicle reaches to the point B, you along with your friend reaches to the same position. It means relative displacement here is zero. Between you and your friend, relative displacement in going from A to B is zero. Right? There is no relative displacement between you and your friend. That is why you are at rest with respect to your friend. Dear students, when we study the relative velocity, we talk about much. It is said that the relative velocity problems are very, especially the river boat problems are very easy if you solve them with respect to ground as a frame of reference. And same I am going to follow. It is said that the experts used to say that, I am not the expert, I am just a very simple human being. The experts used to say that if you solve this river boat problem or airplane wind problem with respect to ground as a frame of reference, then things becomes very easy for you. So dear student, first we are going to solve the river boat problem. We will solve this problem. We will talk that how many kind of problems we can make here, right? Dear student, let a river having the width W and it is flowing with velocity Vr, right? Here is a point A on this bank and there is a point B just on the opposite bank of the river, right? Just opposite to A on other bank of the river, right? Now, dear student, here is a person sitting on the ground, right? This is a person, observer on the ground. So, with respect to this observer, I am going to solve the problem. Let the swimmer begin to sail in this direction. It is the velocity of swimmer with respect to river making an angle theta from the vertical. Dear student, what I have done, a river having the width W, it is flowing with the velocity Vr. As here is a person sitting on the ground with respect to this very person, with respect to this very observer, we are going to solve the problem. Here, swimmer with respect to river begin to sail at an angle theta from the vertical, right? Now, this, dear student, this VSR has one component, this is a VSR cos theta, and this component is a VSR sin theta. Dear student, nothing you have to talk much about. If you are thinking about the component, very simple concept. If this is theta, this is R, then the component adjacent with the angle is a cos component, and another component and the perpendicular component away from the angle is a sin component. This is R sin theta. If this angle would have been theta, then this have been cos component and this have been sin component. So always you need not to create the triangle. Just component which is adjacent to the angle is the cos component, and the perpendicular component which is away from the angle, that is a sin component. Now dear student, look here. The swimmer begin to sail with respect to river at an angle theta. I have taken the two components. The component adjacent to the angle, that is VSR cos theta, and this is VSR sin theta. Now dear students, the first question is asked that how much time the swimmer takes to cross the river. So time taken in crossing the river time is equal to width of river is W divided by, now the very basic concept of mechanics, that the horizontal distance is covered because of horizontal velocity and vertical distance is covered because of vertical velocity. Here the swimmer has vertical velocity component, that is VSR cos theta. Because of this velocity, because of this component of velocity, swimmer will cross this river. So time is equal to distance upon velocity becomes VSR cos theta. This is the time taken by the swimmer in order to cross the river. Now dear student, this is the first problem asked, that what time swimmer will take with respect to river in order to cross the river. The second question might be, what would be the minimum time? What would be the minimum time that swimmer takes to cross the river? What would be the minimum time that swimmer takes to cross the river? Dear student, in this problem, time is equal to W upon VSR cos theta. Look here, when time will be minimum, this is the denominator. For time to be minimum, denominator should be maximum. Now, let W and VSR is a constant. W is a width of river, that is obviously is going to be constant. VSR, velocity of swimmer with respect to river. This is the capacity of swimmer. This is the potential. This is the strength, power of the swimmer to swim in the river with respect to river. So let the swimmer is floating, swimmer is swimming with its maximum capability, then VSR is also constant. Now whole game is played by theta. So for T to be minimum, that is, this denominator should be maximum, and the cos theta has maximum value, that works out to be 1. So T minimum becomes W upon VSR. Now dear student, cos theta will be 1 when, that implies that theta equals to 0, right? That implies that theta equals to 0. Now look here how the diagram becomes. When theta is equal to 0, it means swimmer is traveling in this way. This is the velocity of swimmer with respect to river, right? Theta becomes 0 means swimmer is traveling in this way. But look here, yet swimmer is traveling in this way. But the person sitting on the ground, what he will observe? He will observe that swimmer actually has not reached here. But because of flow of river, swimmer will be observed here, right? So, yet swimmer is traveling in this direction, but swimmer will be observed here. So it is what? This velocity is what? This is the velocity of swimmer who has observed the swimmer to be here? It's a ground, person sitting on the ground. That's why it is a velocity of swimmer with respect to ground. And no doubt this is the VR, right? This is case when time taken is the minimum. Time taken would be minimum when swimmer begin to sail vertically in this vertical direction from A to B, direct in the straight direction. Yet swimmer will not reach here, right? Swimmer in the river will watch that he is heading towards B, but a person sitting on the ground will watch that swimmer has reached here. Rather to reach B, here the swimmer has reached a point C, right? It means this velocity has been this velocity of swimmer has been observed from a person on the ground, and that is why it is the velocity of swimmer with respect to ground. So when time taken is a minimum, from this condition, this triangle is a very important, and you can say that this is Vs square equal to, right? This magnitude Vs square equal to Vsr. I'm just applying the Pythagoras plus Vr. This Vsg I'm not writing, I'm writing just Vs. Vs means velocity of swimmer with respect to ground. If no frame is given, it means we are talking with respect to ground. So dear student, this is Vs square equal to Vsr square plus Vr square, right? From this expression, you can find out, you can find that Vsr, I'm writing here, Vsr, velocity of swimmer with respect to river, mod of this is equal to under root Vs square minus Vr square. This is also very useful diagram while solving the problem, especially for NEET and JEE aspirants. Now, dear student, we find the time taken, the condition when time taken would be minimum. The first thing we find that what time would be taken by the swimmer to cross the river. Second, what would be the condition for the time to be minimum. And third condition, let's talk about dear students, what I'm saying that let swimmer with respect to river begin to sail, making an angle theta from the vertical. He begin to sail in this direction, but it is observed that he reaches somewhere here, or here, wherever be, right? Let he reaches here. So it is what? The distance travel from the opposite point of initial point, from just the opposite point of initial point, right? The horizontal distance covered from opposite point of initial point, this is called the drift. Drift is this BC is the, if you will draw this to meet the swimmer on the opposite bank, but this distance is not the actual drift. Drift is undoubtedly the horizontal distance covered by the swimmer is said to be the drift. But horizontal distance from where? From the opposite point of just opposite point of the horizontal distance covered from just the opposite point of initial point is said to be the drift. And drift is what actually? Drift here, this is the BC. BC is said to be the drift, right? Now, dear student, very important concept that why the horizontal distance, why the drift happens. Drift happens, this horizontal distance, because of horizontal distance is covered because of horizontal component of velocity. Now, we have two components, one is a VSR sin theta and another is a VR. Dear student, undoubtedly VR is greater than VSR sin theta. Otherwise, he would have not been drifted. If swimmer is drifted here, it means VR is greater than VSR sin theta. If VSR sin theta would have been greater than VR, the swimmer would have not come here. So, the drift will be, this is the BC, this is just from a point opposite to the initial point, right? The horizontal distance from a point opposite to the initial point, and this horizontal distance is called to be the drift. Now, this drift will be covered. Why? Because of horizontal component of velocity. Horizontal component is this VSR, and this is a sine component into time taken. Time in crossing the river, right? Time taken. Actually, the time in which swimmer reaches from here to here, the time in which swimmer reaches from here to here, in the meantime he will travel this horizontal distance, right? When swimmer reaches from here to here, dear student, just listen it very carefully. It's a two-dimensional problem. When swimmer reaches here, in the meantime, he will travel this much vertical distance and this much horizontal distance. When swimmer reaches from here to here, either he is going in this way or in this way. Ultimately, he reaches here. So, the initial point from where the swimmer begins his motion, here it is a point A, and ultimate point where it reaches is C. In the meantime, it travels AB vertical distance and BC is the horizontal distance. Vertical distance is covered because of vertical component of velocity, and horizontal distance is covered because of horizontal component of velocity. So, the drift, horizontal drift is equal to horizontal component of velocity into time of crossing. And dear student, you already have find the time in crossing the river, that is W upon, and vertical component of velocity VSR cos theta, that much, right? It was the VSR cos theta, this much. This is the drift. Dear student, this is the drift we observed. Now, question might be asked that what should be the condition that drift is zero? What should be the condition that drift is zero? For drift to be zero, look here, very simple. For drift to be zero, this is the deciding factor. So it should be 0, VR minus VSR sine theta. This should be equal to 0, or VR is equal to VSR sine theta, or you can say sine theta is equal to, this is VR upon VSR. Sine theta, this is the condition for drift to be 0. Sine theta is equal to VR upon VSR. Now, dear students, we have found out the condition when the drift will be 0. Now, sine theta is equal to VR upon VSR. If drift is 0 means the sailor begins its motion from A and reaches directly to point B. Only then drift is 0. And how it is? Look here, let's make the diagram. Here I am making the diagram. That swimmer sails in this direction. This is the velocity of swimmer with respect to river, making an angle theta from the vertical. But he reaches directly, begins his motion from A and reaches directly to point B because the drift is 0. So he reaches to here, begins his motion. Rather he should reach here, but rather he reaches here to make the drift 0. So the person sitting on the ground observes that the swimmer is here. So this is what? Velocity of swimmer or velocity of boat. Either swimmer or boat, no matters, right? And this is the velocity of swimmer, and your river is flowing in this way. This is the velocity of river. So how you can make this diagram? Dear student, actually you can make this diagram justifying the vector analysis. This is the velocity of swimmer, right? And this is the velocity of swimmer with respect to river. And This is the velocity of swimmer with respect to river. This is the velocity of swimmer, and this is the velocity of river. Right. So here this is the velocity of swimmer with respect to river. This is the VR, and parallel to this I am making like this VR, right? And so this is the parallel to it I have made here also, VSR. This graph justifies this condition that this is the river flowing VR DS1, and this is what? This is VS, and this is VSR. From this graph we can write, look here, and this angle is a theta, sine theta. Now dear student, from this graph you can write that VSR square is equal to VR square plus VS square. But if you will apply the vector sum, this VR, the tail of VSR is kept at the head of river, VR. So VR plus VSR is equal to VR plus VSR is equal to VS. In this way you can solve. Now dear student, this is the condition. Here we have solved, we have find out the condition when drift becomes zero. Now question is that when the drift is not zero, can you make it minimum? What is the condition to make the drift minimum? Dear student, let the drift is not zero. Now the condition for drift to be minimum. Actually it is a game of theta. Dear student, so what I am doing, if a graph is plotted between y and x like this is a graph plotted between y and x. If I ask a question to you that where is the maxima and minima in the graph, this is representing maxima, this is the representing minima. And if you draw the tangent, both the tangent are parallel to x-axis. Means slope of these tangent m is equal to tan theta, and that is equal to tan 0, and tan 0 is 0. Dear student, it means that what we apply in order to, if a graph is plotted between y and x, for maxima and minima we apply dy upon dx equal to 0. Why it is 0? Because at maxima and minima slope would be parallel to x-axis, and if it is parallel to x-axis, slope going to be 0. So dear student, here we have to find out the condition for drift to be minimum. So what I am going to do, that drift is depending on theta, so I am going to differentiate it with respect to theta like so, d by d theta of drift, and this differentiation should be equal to 0 in order to find out the minimum drift. Dear student, if you solve, you will get that sine theta is equal to VSR upon VR, right? Sine theta is equal to VSR upon VR. You can solve it, it's not a very tough problem. If you think, then even I can solve. I am just waiting your comment. So, that is d by d theta this upon this. W is a constant, take out, so d by d theta this upon this. Now dear student, this VSR is also, W upon VSR is working as a constant, you can take out and then solve. D by, you can apply this formula d by dx of u upon v, and that is equal to v du upon dx minus u dv upon dx over x square. If you will apply the same result you are going to, that is sine theta is equal to VSR upon VR. This is the river boat problem. Dear students, in next video I will talk about the rain man problem. I'm just my objective is to, when we'll solve these problem based on river boat, At that moment, we'll discuss about the river man problem, and we'll solve some problem based on river boat problem, airplane wind problem, and river rain man problem too, right? So in the next video is going to consist the problems on river boat, right? We will solve the problem on this concept of river boat. We will solve the problem on the concept of airplane wind, and third one is a rainman. We will solve also the rainman problem. With this word, if you think, it's my humble request to you, our dear student, if you think that my videos are helpful to you in your study, in your preparation, then please and please, it's my humble request that please and please like, share, subscribe, and must put bell icon, and do comment on the videos that if there is a problem regarding to my, if you have any kind of confusion, do comment on my videos. So meet you in next video. Till then, bye.